lower the entry barriers for everyone. Yeah, so this is what we do. And before we move to the session and the ground rules, the topic today is building enterprise solution with microservice architecture. Yeah, see if you can move to the next slide. Yeah. So, brief introduction about Sree. He is a very seasoned technologist and a technology strategist, and of course, he's the customer-facing marketing technologist and the leader. He has over 16 years of experience in the IT industry, and currently he is a senior technical architect in SAP Razorfish. And Sree can be reached at his LinkedIn profile, which is given here. You can scan the QR code or move to the LinkedIn ID that has been given here. I am Bhaskar Tripathi. I am a product evangelist and a researcher in mathematical optimization. My main area of research is in applied mathematics and optimization theory, information game theory. I have around 14 years of experience in the IT industry. I have, additional added experience as a data science researcher, and have publications in several reputed journals. And here is my LinkedIn ID. I can be reached at this profile ID. The next slide, please. Yeah. Before we move and start the session, I just wanted to for the benefit of all audience and people who have joined through streaming channels, I just wanted to keep some ground rules that will be answering everyone. By default, we'll mute everyone, and it's my request that while Sree is delivering the session and speaking about microservices. So if you do have some questions, please type in the chat box, and we'll go through each and every single question and make sure that we answer all your queries. So during the Q&A, if Sree decides to pick and choose any of your queries, then he may, answer those queries instantly. Yeah. Over to Sree. Sree, I think it's all yours now.
Yeah. Thanks, Bhaskar. Thanks for the introduction. Good evening, everyone. Thanks for taking time to join. Good morning if you're joining from other geographies. I don't know who all are on the call, but again, I would like to actually thank Anjani and Bhaskar for creating this forum and platform to share all our expertise and technologists who are coming as speakers in this forum and sharing knowledge across various areas. So thanks so much for creating this platform. I would like to start the agenda by sharing the agenda today. We'll look at the overview of the topic for today, which is microservices, and we will definitely look at why we are talking about microservices today, and we will look at some of the key patterns that industry we have actually seen implementation of microservices and some of the pitfalls as well, because those are important to understand when we understand new architectural styles of designing applications. And we will look at some of the key takeaways and follow up with Q&A. Okay. Just to introduce, before we introduce the microservices or distributed systems, I just want to put this slide in the context of the current things happening across the world. As we all know, we are in the midst of the global pandemic, and definitely I believe the topic that we have picked today is still relevant. I know many of the folks who have joined this call, or even who have actually heard about this microservices, would have thought this is 10 years old or 8 years old topic. What is so new about it, right? Why in 2020 we are talking about microservices? It should be all smooth, right? But it's very surprising to see when we talk to clients as a consultants, when we talk to our clients in various domains, it is surprising to see that how some of the organizations have still not adopted to these ever-changing technologies or digital transformations within their organizations. And during these tough times, they are still currently struggling to move fast in the sense to whatever the business needs are there due to these tough times. They have to change some of their processes, some of their ways of working, and still serve their end customers. But when they look at their digital stack, still some of the applications are not built in a way that they could move fast to the business needs. And we see that clearly in our daily lives. Like we know some of the big brands, they're able to do things so fast that we even think like something like this happened like in March, maybe starting of the March or somewhere in the US. Within like few days or weeks, you see things coming from big brands. But there are quite a few organizations and companies in different industries which can't really, even today. I mean, I know some of our clients we have been working with, their things, their applications and everything have been built such way that they're not even like do simple things on their websites to address the current situation. That's how the applications have been built. So I think still it is relevant. Microservices are pretty much relevant. And in this tough times of global pandemic, I think it is apt to actually go and check back to like some of these basic topics which have been there around to be sure that we are designing the applications in the correct way even for the future. So I just want to put out this slide out there to just discuss about why it is relevant still, why we are talking about microservices. Again, in that same context, like if we, like somebody might originally when it has evolved, and I think in last 5-6 years back, I think this was like more of a question of, even I think some of the organizations today question this, like, is this just another hype? Like we have seen a lot of things which have come over the past period in the technology landscape, and this is an architecture style. Is everybody doing so? Is it relevant? There are a lot of questions out there where need to be answered from a technical, not just technical standpoint, but a overall organization standpoint, is to say that whether it is just a hype. But we have seen that microservices is being evolved. It was at a peak where it was a peak of the hype cycle, but now it has actually gone into and entered that plateau where it has been showing some of the ROIs for a lot of businesses, and to clearly show how the organizations are being able to move because they have chosen this architecture style to build certain applications which are critical for them. So definitely, whether this question is a hype or not is up to us based on what we see today. Like in this presentation, we'll know the details of it to have the proper knowledge to decide whether it's a hype or we should just follow the group. Like if everybody is doing microservices, let's just do microservices, right? So that's where I just want to put out it saying that this question need to be answered with some knowledge behind it. And if you look at some of the architecture trends, this is InfoQ, which does the architecture trends in the software software development area. If you see that, like the microservices, as I said, like it has more hype, and it is now in a place where it has shown positively a lot of the ROI of its why one has to consider microservices. But it's pretty interesting to see the correctly built distributed systems, which is at this early adopter stage. Because I felt this was interesting to see because microservices is nothing but like a model of distributed systems, but they term this as like correctly built systems is still in an early adopter state. So I believe there is some within in the industry, like in the organizations, there is definitely a lot of different level of understanding of distributed systems, how they need to be designed and built. So that's where that is still being in the early adopter phase. But microservices applications itself, there have been proven architecture patterns and lot of reference applications out there in the market. Like, so I think the application side of the things have moved on a better um, maturity level, I should say. And the other thing which I noticed, which is kind of I found interesting, is something called micro friends. So this is something definitely it's in the innovator space for the reason that it's I believe like it has been there for around like 2 years or 1.5 year, I guess, if I'm not correct. But if you see, like at least in my experience, in last 3-4 years, I have not seen many clients even talking or knowing about what micro front end is, and that basically is a concept of microservices getting to the front end app frameworks. So which is kind of also evolving, and currently right now as we speak, I'm working with a client where we are actually implementing with micro front ends and with microservices at the back end. So it's going to be interesting and challenging, I guess, but we are up for that. Like, and that area of the aspect is also picking it up. So I just want to highlight that area as well. Okay. As I said, I just want to put a slide about the distributed systems. It's nothing. It's a very old terminology, I guess. Like we all know, even the internet is a distributed system, so it's a very old definition. And if you wanted the typical Martin Fowler's definition, it's down there, or the Wikipedia definition. It's just nothing but like all individual nodes, how they make their own decision and collectively basically serve the applications. That's what we are broadly defining in distributed systems are. And if you already know certain, what a microservice is at a high level, this definitely explains why microservices is a distributed system. And some of the key tenets which I just want to call out about the distributed systems are: there is no shared clock, which means every node is in itself in isolation, and it has no, like, as an application distributed system itself will not have any shared memory, and it has abilities to do tasks concurrently, and you can make it fault tolerant and scalable. Those are the key aspects why anybody would think of like making any application as a distributed system or design that architecture pattern. So we look at this again. This is a basic slide just to show what monolith versus microservices is. I think most of us on the call have already known at this level, like monolith applications which have been there for a long time, and that's what I started off this session saying, that it seems to be very obvious, like, oh, monolith is very old, like this is like old terminology and all that. But if you would be surprised, like there are a lot of applications which makes sense actually today to be as monoliths. It's not like microservices is completely replacing monoliths, but there are quite a few applications which should be moved to microservices which are still running on monoliths. So, but yeah, it is that is what the most of the organizations at like small or mid-level organizations mostly are still struggling how they could catch up to that speed due to a lot of the factors, right? So as we see to the left side, the monolith shows everything is bundled into one box, like where you have layered architecture with a single database serving a lot of the data layer and everything. So it's pretty much coupled with everything. One small change in any layer would need to be deployed for the entire application, and so on and so forth. And again, there are a lot of comparisons between SOA architecture, and which microservices as well, which is also can be looked at as within monolith. There are other optimizations that have happened over the time, like you could modularize, you could do a lot of refactoring and so on and so forth within that monolith. But at the end of the day, it doesn't give that flexibility of isolating each of the functionalities for each service, so that you could independently basically deploy those functionalities of the application. You will have to either do everything or nothing, right? So that's kind of the monolith, but the microservices is where you get that agility, where you intelligently or smartly, actually, I should say, divide your application into microservices, and you get that flexibility into your architecture. So that's one way of looking at it. I know this is like a old way, but I just want to make it a little interesting to show it this way. This kind of shows like where I would see that guy like as a maybe DevOps guy. Like, I don't know. I mean, I just felt this is an interesting comparison visually to say like monolith life was so easy. You just like look cool riding on a bike through the streets, but actually the fun part is when it comes to microservices, it looks something like the right side where you now have a lot of tires. Looks fancy, looks cool, but the guy also looks tough, right? Like, because the team which is actually building microservices, they need to be definitely thinking a lot of aspects than a monolith application is there, and we will see a lot of those patterns and everything in the coming slides. But this kind of gives you a view that if you're thinking, oh, everything should be microservices, it kind of pauses you, saying that, oh, do I need to ride that bike? Okay, let me think about it. Right. So I just want to put that visual. I found it little related to this topic, so I just want to put it out there. These two. Okay. Why microservices? I think we are now into that section where we are looking at why are we talking about it and what does it bring, right? Like to us, like I think, as I said initially and starting as well, like for transforming any business and making the business achieve their goals with their kind of not timelines, but I think with their goals, what they are serving for their end customers, they need to be definitely open for change, and change is something as this. I love this picture because the way it shows how change is an emotional journey. You need to change up like your organization, not just from technologies, bringing in new technologies and some cool applications, but it is all about culture as well, right? Like there is always this learning curve aspect of a thing which always comes as a roadblocker to many of the organizations, where they say that let's stick to what's going on and we'll manage it, right? So definitely for a digital transformation, microservices is one of the enabler, I would say. It's where it definitely pushes to the boundaries to think businesses who are like completely comfortable in their zones to think little broadly and then answer few tough questions to make that move and have the change to think about microservices. So definitely it is that journey which they need to go through every organization. To look at the ecosystem overall, we have talked about microservices, but this slide kind of shows some of the aspects of the microservices, which I think this is one from, I like the way they have put it on the Martin Fowler's site, like where they show this various aspects of microservices ecosystem, right? Like where they are independent services which gives the ability to experiment, like where you need to roll out a feature, but you're really not sure whether this would be beneficial for your customers or not. And this kind of architecture gives you an ability to like deploy a functionality specifically to a specific audience. For example, like if you wanted to roll this feature out to like Denver area or Colorado area for some reason, and you could do that like with this architecture style, whereas if it is a monolith, all your consumer base will get that feature or nobody gets it, right? So you can do that kind of experimentation with this architecture style, and there are definitely experimentation is not just through microservices. We know that there are things like A/B testing and multivariate testing in the old school way, where you could still leverage some of the ways around and do those things, but these are like the ways where you could quickly roll out things instead of relying and onboarding multiple other third-party SaaS tools to do those experimentation. It will be integral part of your own application architecture to do those experimentations. So it gives that for sure. And you could definitely it, as other points also say, it it gives that innovation thing to any business where they can think of ideas and quickly roll it out as well. And from a developer standpoint and team organization standpoint, like microservices kind of gives you, again, this is not like one thing like everybody will be doing in this way, but it does give a ability to structure your teams in a way that you're not actually having like completely teams based on skill sets. Like, hey, this team member knows .NET, this team member knows Java, or this team member knows JavaScript. So it's not of that like a skill set based organization of your teams, but you are more looking from an aspect of every developer. I mean, these days, I think you guys might be familiar with this, is that they are more looked as like a complete full stack developer. That term has been of late little famous, I guess. Like every developer has to be full stack, which means the reason it is getting more traction or more demand is like these days the teams are being organized as a microservices teams. If you think of it, the teams are being divided into vertically, like where the functionality is what drives the teams, not the skill sets. So it's a different aspect of looking how you structure your teams to make this type of architecture style actually work better for your organization. But again, there is no one single answer that, oh, vertical, we have to just structure it vertically, let's do vertically. It doesn't work that way, but there are a lot of factors again that go into in structuring your team as well. But definitely, it's one of the part within the microservices ecosystem that organizations need to be considering as they onboard this journey. Because, as I said, like it's not just technology; it's all about culture as well. So the leadership teams have to think through this from the beginning to how structure the teams as well if they are doing so. Okay, I think the value proposition, it all boils down to three main areas. I mean, again, you can't just name it out as this is my perspective. I see these three as outliers for this as a value proposition which microservices brings onto the table, which is primarily it is agility, which we have looked at and spoke about. It definitely enables that continuous delivery mode more better, like where anything which is the development team is working on, they just check in and you have the ability to push it all the way till the pre-prod and then have it pushed it to prod and things of that nature. And then you can maintain each service independently. And there is no life cycle. That is the part. Other aspect of microservices that you see it as like a independently deployable unit, like where you want to roll out certain specific order function, shipping functionality, you want to make some specific change within that area, you could still do that and then deploy it all the way to the production without even touching the rest of the aspects of your overall application, right? So it gives that kind of agility and experimentation thing which we have seen in the previous slide. And also scalability when it comes to the infrastructure design, you will have context of how these services are deployed and how you could make them more scalable. And with cloud technologies being so prevalent, and again, I feel little it really comes to me as a surprise. But like when we talk about cloud and everything, it sounds so basic, right? Like, I mean, oh, cloud, this everybody should have it, right? Like, but it is still surprising to see some of the organizations still not even having a single public cloud tenant and all of their applications running on-prem, right? So there's a lot of things that need to happen within many organizations. So that's where I don't think the cloud is, I wouldn't term any of these technologies which are like or architecture styles to be like old, though we have been listening to these topics and everything for quite some time. There is a lot to do actually on the ground within the organizations to reap the benefits out of all these theoretical things that we have been learning and seeing from. So that is where it is way more important for us to know these and keep us abreast about these topics to because you never know when you get an opportunity to work with some organization who are actually struggling in this space and they would need everything that need to be getting the benefits out of it, right? So scalability, I think, still is an issue, like where the organizations have not been moved to cloud. So definitely microservices gives that agility along with, like when it comes to the cloud infrastructure, to have it more, make it scalable. And fault tolerance is definitely possible because of the very nature of the distributed systems that we are seeing. And microservices allow you to deploy those individual services and design those so that even if one thing fails behind the scenes, the end consumer will not come to know about it, right, at all. But you handle that gracefully, like within that context of the boundary context of that particular microservice. So there are ways to tackle the fault tolerance as well, which kind of is definitely comes in the monolith world with a lot of code adding or code plumbing and redeploying the entire thing. And it's like there is a lot of things to be done for handling fault tolerance if it were a monolith kind of a function application. So those three are like at a high level the value propositions which microservices bring. But again, as we know, there are no silver bullets. So definitely microservices is either one, right? So definitely there is art involved as well. Like when you are actually working with any organizations which are very named to this area, they need to start with a strategy of how to onboard microservices. If somebody at a C level or like even like at a SVP level person just says that to their team that, hey, we need to move this into microservices, definitely if you have to raise a question asking where is the strategy, they're like, how are we saying microservices is a fit? So definitely it's not a silver bullet. So I would encourage everyone, like if anyone has the opportunity or already have been working, that's a different thing. But I think if we are embarking on this microservices, let's not implement that or like design it just because it has to be microservices, right? So we'll have to think it like from a little broader perspective. So definitely it's not a silver bullet. Okay, so that segues into this next section, which is about the patterns. Definitely important for us to understand. But before we move on to patterns, let's take a closer look of what microservices, right? Like we have been talking at a high level, like on what that is, but technically what it looks like. If again, this is maybe a 101 kind of a slide, but still I want to have it here because if there are folks who have not got introduced, that
I would pause you, Siri, here and just ask people if they have any question, they can put in the chat window if they are going with the flow or.
okay.
Yeah.
Oh,
So
I thought we are taking
yeah, I would
at the
encourage
end.
people to So if you're loving it or so you are excited for it, so just say yes, ping yes, and so Siri would continue. If you have any question, you can put it there, and obviously we'll try to answer it. Yeah, Siri, you can continue. Yeah.
Okay. Yeah. Thanks, Neil. Yeah. So let's take a closer look at the microservice. Like, so what it is, as we know, it is a service independently deployable component, which we all saw so far. But definitely, it's not a service in itself, right? Like, it's not web service that we know, which we have been working so far with, right? Like, so what makes it different in the aspect, right? Like, we can take a look at it, like what are the other parts to it. So this service will be whatever the context of that service is or the functionality is, it exposes to the outer world through APIs, right? Like, so it has, every microservice would have its endpoints to do various things. And we could call them as operations, like where it would define the operations into two categories, actually, which is one of them we can term as commands, which are more of which would define it as more in the old world, like you can say it as a CUD operations, which is create, update, delete, like whichever changes the state of the things, a persistence layer, right? So one of the operations we could categorize as commands, and the other one is queries, right? Queries are nothing but the read mode, read aspect of the operations which are defined within the API. And for the external applications or external third-party applications, or even for the consumer application, the way of communication could be mostly synchronous using REST, or even gRPC is becoming a little famous of late. Like you could think of those, or even any other protocols that might be suiting your needs. The external communication would be more of synchronous mode. But the beauty is internally within the microservices, the communication needs to happen asynchronous. You can't make a microservice to be called through asynchronous and have your client application wait for the outcome to come and things of that nature, right? So you need to definitely design and think of the asynchronous messaging internally within amongst the microservices that you have within your application. And that happens through publishing events. So your microservice is not just as a REST API like endpoint, which is just serving the cut operations or read operations, but it could also publish events to the event publisher. And at the same time, it could act as a API client, which could invoke other operations, right? So it could communicate with other services through as an API. So it is actually acting as the API client, and it could subscribe to other events at the same time, right? So as it is publishing, it is also subscribing to other events, so that it is not basically dependent on the state of the application, overall application. It has its own context within the boundary context as you define it, right? It just knows if it is an example, if it is about a shipping microservice, it doesn't need to know anything much. It wouldn't store any persistence about what other aspects of the application are, like, for example, order management or customer or any of that nature. It just knows more about, or its boundaries tied to shipping. But definitely every microservices needs to be having certain persistence database, which is basically could be anything like based on the need of that microservice. Either could be relational or mostly NoSQL, based on what that service is built on. So that's where every individual service would need to have its own context of the data, which is private to this service. If any other aspect of the application needs that information, that is the reason we have this API, which we have been exposed from this microservice. Okay, so these are various aspects of the microservice that we want to show you here. Sorry, if let me know if my audio is not clear, Anjani.
It's clear.
It's clear. Okay, thanks. Okay, so before we look at the patterns again, just want to give the high level, like why we need to look at the patterns again. As we know, once this has been adopted, like I said, like if somebody just says that, hey, let's go implement microservices, and you start with like 5 microservices, and soon it becomes a noodles of all communications happening everywhere, right? So we just can't start without like looking at all the different aspects of the pattern that we need to look at. So it was a monolithic hell, but it could very soon convert into a microservices hell where it would look something like this. So definitely we have to look at all the patterns that need to be taken into consideration. So this kind of again shows at a high level what are different areas or the within the microservices architecture that we need to consider the patterns for, right? So it just shows like the application architecture when you are migrating from monolith to microservices architecture, what all things we need to take care of. Like at a high level, they are categorized as application patterns, application infrastructure patterns, and infrastructure patterns. And then you have communication patterns as well. So the difference, again, I'm not going to read the definitions, but these primarily are developer focused at the top. You can see it that way, and this is more of ops. So you can, overall it is like DevOps, which need to be considered like in various angles, right? Like, so specifically when it comes to decomposition, for example, I'll just take that one to look at it, right? Decomposition pattern mainly talks about when you are moving a monolith architecture to a microservices architecture, you need to think of like, or even for that matter, you are building a new application using microservices. You need to start thinking of how do we start breaking this application or the functionality into different microservices, right? So you got to, there are again a couple of ways you can approach the decomposition, where you can go the domain driven design based, like where you start identifying all the various domains within your business functionality and try to list out and see what structurally makes sense to divide as a microservice, and you have to decompose the application to based on the domain design. Or you could actually look at the business functionality level, like I was saying, like shipping, ordering, like what is the high level business functionality that you want to build a microservice for. But you have to be a little careful based on the context. It's not one thing is right and the other thing is not, because based on how complex your business is, it could, one would fit for some companies and the other style would fit for others, right? So if it is a very small scoped application that you're building, maybe the business functionality wise of things might work, but domain driven has been, I think, more adopted like at this point in organizations to decompose like or look at the microservices. Again, there's a lot of cross-functional teams involved in the decomposition pattern, like where you need to work with your functional analyst, the product manager, like who actually defines the requirements and everything, and then try to identify what makes sense to as a boundary context to define as a microservice, right? Because at the end of the day, the decomposition should not lead you with a giant microservice which would have a lot of business logic within it, but there are other microservices which are barely doing some minor transformations, right? So then you are not actually thought through about how the business functionality is spread out or the domains are laid out and dependencies are between those domains, where you end up with one big microservice which is doing everything. So you're kind of creating a semi-monolith there, right? So that's where decomposition patterns are really important to consider. And if you go to the migration pattern, like where this is a scenario of strangler pattern actually helps us when we are working with organizations which have already, which is most of the cases that happens, right? Like where they have a monolith application, now they are thinking to adopt to this new microservices pattern. So the strangler pattern basically allows you to give that, like what you say, like a gradual migration into the microservices. You can't just rip off the entire monolith and go into the microservices at one shot, but it gives you an ability of like adding any new functionality. If you need to add any new functionality to the application, you can think of making it as microservice. Or you need to make any other considerable changes. You want to refactor your monolith, then you can consider how you can split that into microservices and then slowly evolve it over the time to make a lot of microservices over the time period where your monolith keeps reducing. So that's it looks good on the picture to show you that way, but believe me, I mean, you can imagine as well, like it's not that straightforward, right? Like you can't simply rip off some functionality from monolith and then start building microservices. You will have to, this is again, migration pattern is also something which you'll have to go a little deeper when it comes to the implementations and real scenarios to actually see how this thing actually works for applications within organizations. The other one, which patterns, is about external API patterns, which is and comes under the application infrastructure pattern, which we saw initially. This is more about like how do we make sure that the external applications, which are now this like they talk about omnichannel, multiple devices and everything, as well as, right, like, so there are third-party applications, web applications, mobile applications, all those consumer applications which need to talk to your backend. The only disadvantage of not having some layer like this, like API gateway here, and having each of the consumer application directly calling the microservices, is where you lose, or you not lose, I would say, like you would end up building a lot of repetitive transformations or there are definitely, like, imagine like this web application is calling service B, service A, all the other consumer applications are also calling those directly. So you now start suddenly building all this logic of how to handle this incoming request based on what consumer is calling within your service. So you start ending up coding the problem of how to resolve multiple things, security, or there is like transformations, everything need to be now problem of those microservices, which is not really the reason that you are creating microservices, right? You want to separate out the code for where you are basically having only that business functionality code within that microservice, and everything else should be separated out. So this pattern basically talks about introducing the API gateway where you manage that cross-cutting concerns of security, either it be transformations or like load balancing, even for in certain cases. It would do, API gateway would take away from the microservices, and the consumer applications will just have one endpoint to call, which is the API gateway's endpoint, and they will always call that, not knowing what is happening behind the scenes, right? So that gives the ability of this layer to introduce that API gateway. However, you have in this model, you have one unified protocols. You could actually introduce other protocols, but there are implications within API gateway if you have to change that, like transform and everything, because it could actually do the translation from REST to GraphQL if needed. Like, for example, mobile might need like a different, like limited information from the same service. So it might use a GraphQL. API gateway could intelligently make a GraphQL protocol to just get that lighter version of JSON and return it to the mobile application, and so on and so forth, right? So you can basically separate out all the concerns into the API gateway layer. The parallel pattern for the external APIs is, if you needed the ability to directly have the consumer applications use different protocols, like in the example I gave you, GraphQL, you need not lock it with one API gateway where everything is being handled. You could introduce something called a backend for frontend, which is also like a layer which is specific to that consumer channel, right? Like in this case, as you see, each of those backend for frontends would be then able to communicate with the microservices instead of directly the consumer applications calling it. So here, what it is basically doing is it could be looked at as like a micro gateway as well. Like if you look at products like APG and all, they are actually providing both offerings, like where they could give you a entire API gateway, or they could even go this way of micro gateway where you could define it for each of those consumer applications and configure it that way, so that you're not tying any specific thing for all channels within that one. So it gives more independence of, like, if you have to do any specific things within one channel, you could do that. So this is that backend for front-end pattern that it is. The next pattern is service discovery pattern, but I just want to give you a high-level introduction of what service discovery is. Like, because of the microservices need to be designed in a way that they are fault tolerant and resilient and all that. Like, you're not having a one endpoint for a microservice all the time, right? So they keep, if you think of the cloud infrastructure, they are in ECS, like AWS. If you take an example of AWS, they are being deployed into ECS tasks within Fargate deployment model, and everything is changing. They are all within an auto scaling group, and the instances are changing very frequently, right? Like, so based on their health checks and everything, that gets provisioned again and again. So the service endpoint keeps changing. So there are a lot of other architecture patterns that could be used before to keep that problem to a different layer. Like, you could think of it as like moving it to the load balancer, application load balancer, and things of that nature. But in simpler applications, you would still need the service discovery to happen. There are ways around, like, not to have the service discovery at all, but that requires a different architecture. But service discovery is something which is need to be thought through, like within all these layers of the microservices, where you need to do that. because you have to discover where that endpoint is and call that specific endpoint based on various factors. So there are two patterns again, like you could do that registry of service either at the client side where your client application is aware of which it is basically reading, asking the service registry that, hey, tell me the endpoint which URL I need to call, or like for the service A, and then it gets that, and then the request is sent to that particular service, right? And all the services, they make sure whenever they are going up, coming up, they just register in the service registry. So this is kind of a model where the client is aware of that particular registry, where you call it as client-side service discovery. And again, one has its own disadvantages and other has its advantages, wherein more people actually go and design it using server-side discovery because they want to keep the clients as independent as it is. They need to be to keep it light. But here you are basically introducing a router where it does the job of doing the registry lookup and everything, so that the client is here independent. They just will always call one thing. And most of the cloud deployments, if you see for microservices, they follow this architecture pattern where you are either calling always one, like either the Route 53 or like application load balancer, which just sits in front of everything, and then that takes care of all the service discovery and all other problems which need to be tackled to call the right instance of the microservice. So this is where it is important, like to not have a like a pattern where the client is directly calling the services microservices directly, because definitely those endpoints and everything keeps changing. So the client has to keep knowing about the changing, the relevant URLs and everything for those services. So we looked at this communication patterns a little while ago, like where we saw the slide where each microservices, where they are built, they are exposing the data which is private or within its boundary context through an API. And also the other pattern, like where for the asynchronous communications, is something which happens to events. Like we use something called event backbone. Again, it has a lot of like comes in different infrastructure solutions for building the event backbone, where you could, the microservices will be just publishing and subscribing to the event backbone, and then getting the messages of that particular state, and then managing what needs to be responded to the incoming queries, right? So there are two ways, like either you expose the data through APIs or communicate through asynchronously through the events. So mostly, I think the design suggests to definitely think of like designing your microservices to communicate within them using asynchronously, using something like an event backbone, so that you are not building the dependency on one instance of it, right? So even if it fails, you'll have to be still able to read that event and come back to serve that particular request. So that's where it is more important to design it in an asynchronous method. Yeah, event-driven architecture, which we just now looked at. Like it is more like, I like this slide, which is old, which is from 2017 Gartner, but it is thinking of it as like in the context of microservices. Again, the event-driven architecture term itself has broader meanings and different interpretations, but in the context of event-driven architecture, we are talking about how we are making the communications between each services, right? Like where we are not worrying about preserving the data, but we are actually trying to respond to the events. That's how we make them communicate asynchronously, and so that we are not worried about if one microservice is out of like reach, then you're not worried about like how the context will be written, because the events are central. They could again come back and just have read that set of sequence of events and be able to still serve that thing. Instead of looking at more database focus, right? Like if you look at the left-hand side, this is where how we build the monolith applications, where we used to have that big central database, which is kind of key to the whole application. If that goes down, there is no way like there is nothing going to be up, right? Like all the application depends heavily on that data. But here we are actually driving the communications within microservices through the events driver. This is another pattern of asynchronous messaging. Again, there are a lot of ways you can handle like how each microservices need to communicate with other. This is one way of like designing where you need to scale the individual microservices based on like how the asynchronous message is coming, right? Like so, if you think of having a microservice send a message to a queue directly, right, and then have the other microservices pull that queue, there are implications of scalability there in that architecture. So one of the architecture is called fan out architecture, where you could think of having a topic like where you have, like if I map it again to the AWS language, you have SNS, which you could use here, and simple notification service, and then you that public everything all the queues, individual queues will be subscribing to that particular topic and accordingly delivering that specific message to those services as needed, right? Like so they don't need to this SNS topic doesn't need to publish this to entire all the services, because some messages might be relevant to this service and some might not be relevant to this service, and so on and so forth, right? So this gives more flexibility for each of the individual services to subscribe through the queues only those relevant topics. And for some reason, if some service needs some messages in an order, they could design it in that way as well by choosing specific infrastructure here. So this kind of gives a more advanced level of like how you can asynchronously communicate between microservices, but at the same time make it scalable as well. And there are quite a few observability patterns which are like, you can think of them as little like cross-cutting concerns as well, like where logging, performance, how do you do the centralized logging and everything for all the microservices, because especially debugging, troubleshooting and all that becomes a little more complex and involved in microservices world. So that's where it is more important to think ahead, like of what patterns will you be using, or which tool sets we'll be using for having these microservices log all the errors and everything, so that you could be troubleshooting them correctly. So definitely lot of these things are need to be hashed out before getting into the implementation of microservices. And again, one of the key advantages that we saw about microservices is to design that being it fault tolerant, right, and making it resilient. In this case, like if for some reason your payment service is breaking, you don't need to let the consumer know that a 500 error or whatever, like, or payment service is unavailable or whatever it is, right? So you just send a message saying that the payment has been taken, we will confirm you, or whatever, like the email communication, and just send a synchronous message back to the consumer saying that something happened at my end. Your payment has been taken, and you statefully retry those failures at your end to make sure that payment service at the end of the day passes, right? So there are ways to handle this as well. Again, from within the AWS infrastructure, you could use something called AWS step functions and everything to manage that workflow of how you statefully manage this thing within that boundary of that microservice, and not worry about actually handling it in a synchronous way to the end consumer. So definitely we need to design the microservices in a way thinking that at any point of time, anything could fail, right? So that has to be in the mind all the time to make sure that your design is highly available, resilient, so that your fault tolerance is in the design. So definitely that is one pattern that we need to look into in designing our application. The other one, which is famous, which is around the container orchestration. Again, when it comes to microservices, the deployable unit you could think of is like a Docker image, or like you want each microservice to be, usually it is designed that way. Like again, there might be nuances of how you could deploy microservices, but most broadly, each microservice is bundled into a Docker container, and then those are deployed onto the infrastructure, like wherever ECS or Fargate using AWS infrastructure. But the thing is, at certain point, the managing of these containers becomes tedious, right? When it's not scalable, if you don't think of a container orchestration platform or like a tool for that, and most likely the industry is choosing and going towards Kubernetes. As we all know, it is kind of comes with microservices. Is like, hey, if you are designing, you tend to see that Kubernetes being there in the stack. The reason is uh, very much is that like you need to manage the containers, how they will scale across the microservices when they are being managed within the cloud, right? So you need to have a container orchestration tool to manage, take off the responsibility from the services itself to make sure that the each at all times all the containers are available for services, right? So the services themselves will not need to have any code for managing those availability and all that. So that's where you take something like Kubernetes to manage that for you. I think that brings to the next section around pitfalls, which is at a high level. I just broadly mentioned again. There are quite a few pitfalls that you can get into when you're designing into microservices. But one ability microservices gives that, like as I talked about the vertical teams and independent teams for each of the technologies. Like for each of the microservices, there could be scenarios where the teams just go ahead with their choice or comfortable choice of technologies, and suddenly you realize there are like 10 application teams which have all microservices built on like 20 technologies, and now you are struggling with managing all the deployments. You have like tech tools all over the place, right? This is more of like a enterprise architecture thing, which usually most mature organizations usually have it within the organizations, which say that we would approve only this set of technologies for these type of applications, so they have some control. But I mean, especially like for any organizations which do not manage that very well, one thing to watch would be to not have that too much a broad set of technologies being brought onboarded, because the one thing is over the time period, definitely keep the technology versions will keep evolving, and then the management becomes a big burden for the DevOps team and everyone else as well, even for the dev.
Guys, just to update you, this is 10 p.m. I believe you're okay to extend it for another 5-10 minutes.
Yeah,
And do I just wanted to let you know that Siri background is more around being a solution architect who directly handles client, who directly pitch into different proposals, and so he's talking more in terms of what different client would love to hear at this stage when we are in the middle of digital business transformation. When you talk about fifth industrial revolution, fourth industrial revolution, people and the client are also transforming together with us, and people like engineers like us, or solution architects or enterprise architects like us, has a big role to transform our client when we actually pitch in with the new ideas. So Siri is giving a very practical view. Obviously, for few people who may be a little who have started a little late on microservices, this may look little boring or little this may goes like they may not feel that they are understanding everything. But once we bring out another session soon, which is more around the very basic concept of microservices, then once you replay back the series session, you will get a very uh, a very concrete gist of how do you package your microservice platform, which solves the purpose for today and for the next 4 or 5 years practically. It's not theoretically, but practically, which sells, which works, and so try to
mhm.
understand it. If you don't understand it, don't worry. We'll have another session which will be very basic, and then we'll have another
Sure.
coding version of it. Yeah, Siri, please.
Yeah. Yeah, definitely. Yeah, thanks for talking that. I think, yeah, it could go very broad as well and deep. If you wanted a specific focus area within microservices, we can definitely look into that. But this was, as Anthony mentioned, at a angle from where you need to talk as a consultant, how you would talk about like microservices and why it applies and what matters and how it should be designed, things of that nature, right? So we are not discussing more of the implementation of like tool, tech stack, and those type of images for the microservices. So yeah. So I think, yeah, just to continue on the zoo of technologies, yeah, I think I made the point. Like we just need to watch out for what technologies we are choosing for each of the microservices. And there is this ideology of like having a shared database. At the end of the day, they are what we are designing is like we are breaking the application into microservices, but at the end of the day, some of the applications tend to introduce a shared database, like for context or like some common functionality. Let's design a database where all the microservices can read. But by the way, you are basically making again a monolith there, because now if that database has to change, there will be implications across all those microservices, right? So if introducing that shared database itself kind of kills that purpose of making those services independent, right? So they're all now kind of dependent on this one. So definitely watch out for not designing any common databases or anything of that nature. And this distributed monolith would mean is like a sequence of calls from like how the intercommunication between the microservices happen, right? Like, so if you design it in a way that order calls shipping calls something like pricing and so forth, you start building that in a dependent way, so that every microservice is directly calling the other thing. So if a shipping thing breaks, your order should not break actually, right? So just because you have just called into this thing, now the order doesn't know, oh, the shipping service has not returned something, and now the order is in limbo, right? Like, or it just returns error or something of that nature, right? So the design itself should be in a way that you're not unknowingly designing a distributed monolith, right? Like, so it's almost like modular application that you are breaking your monolith into functions or something of high level modules, but it is still at the end of the day big monolith, right? So you got to watch, like, just microservices not just about splitting them into small pieces, but also has how you manage your communications and make it asynchronous and independent, so that each individual thing needs to be able to respond in any case or scenario, right? And similar to the shared database, there could be an event monolith. There is this concept of event store where you start. Um, Event monolith is like where you start storing, instead of data, you start storing all the events in one pattern. Right now, you're making that as like, if it is at the end of the day, if you look at it, the infrastructure, technology stack, and everything might be different, but it is at the end of the day like same as like a shared database, right? Instead of data, you're storing events here, and every microservice is dependent on those events to read to be able to process it. So you need to have like the event backbone to be built in a way that each microservice only cares about certain specific events, and it could still function if the other events are not written properly or not being read properly or anything. So within that event backbone, the design has to be specific as a unit for each of the microservices. So this is kind of little interesting to manage that. It seems to be straightforward, but it is not actually. So the event monolith has to be washed out as well within the design. And shared libraries, this is something like frameworks, right? Like some companies tend to build these homegrown frameworks and libraries, which they say, hey, this is a homegrown library, everybody should be using this. Right now, you're building microservices. Now, even for that, you will start using shared library. Then again, it is not a good idea, because now, again, you have something common. And the release management of these microservices will be now tied to the shared library, right? So there is, again, you're losing the ability to quickly deploy one functionality to the production. And same as monolith UI, which we saw as a micro front end, like, so that is evolving. But this is something also which you need to keep in mind, is like you don't build a big giant UI application and calling microservices, because at the end of the day, the application is the entire application. If you have to make some change in the UI, you will have to build the entire UI and then deploy the entire UI. So you will have to just make sure that your monolith UI has to be also considered sometimes to be tied to the functionality, and so you can break it into micro frontends if that suits your architecture. I think the key takeaway is definitely assess microservices architecture fits your use case, which is in itself art. I would say, like, there's no easy way to do it, and then your organization need to be definitely have a right culture to fit. If there is no maturity around cloud, DevOps, and agile culture, and you are jumping onto microservices, that would be set up for definitely a failure, because they need to be having certain maturity level in cloud, DevOps, and agile projects. Without that, microservices management becomes tough. And again, migration approach has to be strategized. You can't just jump on to break the monolith into microservices, as we saw, triangular pattern and everything. So we need to consider those, and of course, avoid the pitfalls. And it's all about patterns that we need to definitely take care into while designing this. I hope you guys got the high-level view or a different angle of microservices as part of this session. I mean, everyone has different things to consume from these sessions, but I think this gives a different perspective. Hopefully, that has helped you guys. But I just want to leave this with this thought that don't try to get to hire this guy called Chief Progress Inhibitor, where he just has microservices as a tool to say that, hey, just go implement microservices without much thinking, and then definitely he will take care of inhibiting the progress to the entire organization. So let's not be that guy to hire that one person in the organization. Okay, with that thought, I think I will hand it over to Bhaskar and Anjali.
Sure. Thanks, Sri. I think it was really insightful and long session. I hope most people got some value out of it, especially those who are like architects, aspiring architects, enterprise architects. Yeah. So thanks again. So before we close this session, I just wanted to reiterate that since you guys have spent your time and energy, so we are also distributing the participation certificates. And the way to claim your certificate is you'll need to go to fifthir.com. I also typed that in the chat window. So in this, let me share my screen and show you how to generate a certificate here for the session. I hope everyone is able to see my screen. So all you need to do is, key in your name here and, the other details, and you'll be able to generate your certificate. And the event code to generate the certificate is, so I'll announce this, secret code 3 times, and I hope that would help you to generate the certificate. So the code is AAPA. That's A for Apple, A for Apple, P for Poland, and A for Apple. And once you are able to, type in this secret code, then you will be able to generate a certificate. Let me know, guys, if you are, struggling to generate the certificate. You can also, as I'm showing over here, we also have our Telegram channel. So just in case you have any issues while generating the certificates, you can, just ping us on our Telegram channel and we'll help you. So that's it. I'll just go back to some questions. Shri, I'll just go back to some questions, and just in case there are some unanswered questions.
Okay.
I'll just get back to you.
Yeah, I'll try my best to answer. I think, yeah.
Okay. So I think one question from Bharat is, so I think there are few questions and thoughts, I'm not sure, but yeah, it is mostly a question that it makes sense in large interface with independent of styles services, for example, hospitality. So yeah, that's true. I mean, the number of interfaces that you have, it also becomes a potential, candidate to evaluate the services, whether microservices should be implemented or not. The question is, are there any other criteria to choose microservices?
Yeah, I mean, the question is more around like to know whether microservices fits your use case or not, if I understood that question correctly, right? I think definitely like one thing that you need to be looking at, like what is the reason you are doing, why you want, what exactly you are trying to get out of it, right? Like is it agility? Is it the way your current application doesn't communicate well back to the consumer applications, like not fault tolerant and those type of things? Three key things which I called out in my slide about drivers for microservices. Those need to be answered like well by from a business standpoint as well to see whether that is the reason you need to look for microservices and accordingly go for that. But I think there is no quick answer for that. Like it has to be thought through from what is the business requirement and also from a tech stack perspective, what you currently have, and a lot of other revenue factors also come into picture, right? Because sometimes the maintenance of monolith application becomes too much like for companies to spend on. And microservices, again, it's not the key driver, but there are scenarios where we have seen that you could actually reduce costs because you are deploying everything on cloud, but at the same time, overall long-term maintenance is going to be reduced. But definitely, there is that initial what is a capital budget that you have to invest on, like to build this complex microservices application, right? So there are a few other cost factors also which play into for that decision. Hope that answers to an extent, but yeah, it's not an easy question to answer.
Yeah, I think it's a multidimensional question. The next one is, what level of ETL should be done when the professional ETL product uh, must be considered?
Sorry, I think it was not hi Bhaskar. So
Hey,
I think it's not framed well. But my point was when we were explaining API gateway, so it was somewhere resembling between with this ESB, which is Enterprise Service Bus. So
Yeah.
I was getting confused that when to choose the ETL or the transformation which you mentioned in explaining this API gateway
Mm-hmm.
versus the ESP product, which is generally we put in any enterprise system.
Yeah, I think ESB API gateway. ESB is like more of how do you say, like it's multi application, like it's at an enterprise level, right? Like all the applications communicate through this one big middleware architecture, like which is the unit is called like ESB, right? Like usually financial institutions and everything, they pretty much rely upon that infrastructure and everything, right? But this is more in the context of like any applications that you're thinking of, like web applications or mobile applications that you're building and everything, right? Like so it it's not similar, I would say, but at the same time there are some commonalities. So the API gateway also has basically it centralizes those common concerns. As I said, one of them is transformations, right? Like if your incoming call has transformed into certain way, you could have build that into that API gateway, and then that would do it for the client application. So the consumer application doesn't need to worry about how to call this so that my backend understands. And also security, everything is centralized so that like ESB, there will be a API gateway team as well. Like it will manage that whole infrastructure, but there are definitely differences. I think I'm not very clear on exact differences, but there are commonalities, but it is not similar also.
I would like to add here. So ESB is obviously, as Siri said, Siri exactly said, it's a middleware tool, right? So it's more around. It has been into the system for long, much years. I think more than 15, 20 years. So obviously the name has changed a little with the time, but it's more around, it's a enterprise application where you if you have to pass the message, there are two parties who are throwing who are going to receive the message. One is going to send it, another one is going to receive it, either in a different form. Here with the API gateway, it's a front end, it's like a facade. So it's more like you are opening up a room for your whole set of application for the outside world. Obviously ESP also gives you a opening world for outside, but it has a different purpose to solve for. API gateway has a different purpose to solve for, and this has API gateway also has evolved with the time, because now the world has shifted from the SOA, or what do you say, the world has shifted from the SOAP based services to the REST based services. Things have changed a little, and then because of microservices, the complexity has come up at a little higher level in terms of how do you expose all these services. In the monolith kind of world, you had multiple DLL, and then you used to integrate it with different forms or app, or a middleware class, or by any way. And when these applications used to pass message to each other, obviously they used to use the ESP, definitely. But here the single application, you can consider it as a microservice. So in a microservice, there can be enterprise microservice. There are different way with solution microservices. For a whole enterprise, there can be a single set of microservice responsible, and it can be so complex that you will have, like, once you start designing, you find out how to solve those EGBE problems. But the thing is, one is for interfacing your small chunks of services, building blocks to the outside world. Another one is strictly meant for passing data. For passing data, now things has evolved a lot, because there's a lot of more load on the message and communication, and so a lot of streaming services like Kafka, um, RabbitMQ, and multiple tool like Rocket, uh, Apache Rocket, and I forgot the name, which Alibaba has implemented. A lot of tool has come up. There are different cloud implementation that has come up, like Service Bus and Simple Queue Service. Yes, one of the oldest implementation of it. But obviously, I would not say Simple Queue Service here, because it's much more complex than what SQS can handle. It's more around streaming messages, more around streaming a lot of data in a minute, second, and then replaying the record and the request. Because when you play with the microservices, that's what I say, right? Let the message to be passed somewhere, and there is another application or complete enterprise application is handling your messaging and replaying is able to replay your message. Obviously ESB also have those features, but it was meant for message passing, and more traditional, classical, colloquial way. Obviously ESB also has evolved with the time. A lot of new feature that has come up, and it cope up with the new industry norm. But technology has also evolved with the need, and now uh, somewhere I feel that the work of ESB inside microservices is replaced with the tools like Kafka, and different implementation version of Kafka, which serves the streaming. There are different cloud platform, they have a different implementation similar to it, and in a shorter term, or in maybe in a more useful term, or a low use term, is you can also use SQS, RabbitMQ, and multiple message queuing tool also, if you don't have a need to implement a tool like Kafka. And when you talk about multiple microservices or multiple platform, like you build one microservice A, it's itself is a huge galaxy, and then the another galaxy of microservices. Think like it's a Star War going on. One galaxy of microservice, and there is a Milky Way galaxy of microservice. Another one is Andromeda galaxy of microservice, and there is a enterprise service, or bus, or there is a universe bus. There's a uh, there's a bus where you can transform your spaceship from Andromeda galaxy to Milky Way, going through a black hole, something like that. So that's how you can understand the difference between both.
Thanks, both of you.
Any other question?
Yeah, I think there is another question from Shakti Veshwar Sharma.
Yes.
Do we have solutions for remote neural monitoring, electronic harassment, and gang stalking on
Well,
high rise in India?
I think Bhaskar, you are the right person to answer here.
I think probably it's not related to microservices per se. So it's a larger question on the data security part and social engineering part. So maybe I think we can discuss this question on Telegram channel. I'll just request you to join our Telegram channel. I think we can have quite a detailed discussion, and exchange insights on that. Yeah. I think that's all. Yeah, sure. So let me share my links.
And there is a Python
Share
only data science channel also. You can share that WhatsApp link also. So I think
yeah.
that will be
So I'm
more
sharing
specific.
the links to all our channels. I have shared, for if you want to, register for all our mail updates, we do have, automatic emailers, subscription emails, and I've also shared the Telegram channel and the other YouTube live and the streaming channels. We have all the material in the past sessions and all. Cool. All right. I think we are good for the session. Thanks a lot for sharing all these insights. I hope people.
Yeah, thanks again.
Yes, that was really insightful and a lot of learning for all of us. Yeah.
Yeah. Thanks everyone. Thanks for joining.
Thanks everyone.
Thank you.